Alright, today I'm going to show you how to use KISSlicer. You can go to Google and search for KISSlicer, or you can simply go to KISSlicer.com. Click on the download link and download for the platform of your choice, whichever one you're using. I'm using Linux 64. Download KISSlicer and extract it to the directory of your choice. And what you're going to do is you're going to run it from the directory that it's in. Okay, so as you can see, once it's extracted, it's already executable on Linux systems. If you find that it's not executable, simply run this command here, and that will make your file executable. But for now, what we're going to do is take a look at my setup for KISSlicer. If you didn't have KISSlicer set up already, what you would do is you put KISSlicer in its own directory, and upon first startup, you will have automatically generated these files. And what these are the default settings for KISSlicer. So what I'm going to do is just take you through my settings, and the way you're going to go ahead and start it up is // that means to execute in the current directory, KISSlicer. Okay, and when it opens up, you might not get these tabs showing, they might be at the bottom, but basically you just go down here and click on one of the tabs. Okay, I'm going to give you a quick rundown of all of these fields. It's going to be fast, so you might want to pause the video and go back if you don't understand something. But just for time's sake, I'm going to do this very quickly. Your extrusion width is going to be the opening size of your nozzle. Whatever your nozzle, your hot end nozzle says it is. A lot of these are shipped at 0.35 millimeters, 0.4 millimeters. This is a 0.35 millimeter that has been drilled out to be larger. So this is my setting for the hot end for this printer. If you ordered a 0.35 millimeter nozzle, you would type 0.35 in this. Infill extrusion width, this is something you might want to play with if you wanted to use less material on the extrusion on the interior of your model. This is some super user stuff that basically just saves you material. A cost saving measure, basically. Layer thickness, this is going to be the layer thickness of every layer that you print. It will print one layer, move up by this amount, and print another layer. Seam heighting. Seam heighting will move the start-stop position of your outside loops inside or outside by this multiplier. Basically, if you have it set to 0, it will pull the start-stop position inside the outside loops, the skin loops, and if you have it set to 1, it will push them farther to the outside, making the loops sort of show up like bumps on some printers. Basically, this is something you're going to have to play with if you end up with bumps on your model or seams on your model, and you'll know what I'm talking about when you see them. Jitter, this is a setting that you can set from 0 to 360, and as you can tell, probably tell 360 is in degrees, and it will randomly select a start location along that set amount of degrees that you set theta to be. So a good rule of thumb is just to leave it at 0. If you don't, then you end up with nubs surrounding your model. If you have a circular model and you don't mind nubs and think of them as artistic, then yeah, go ahead and turn it on 360. It'll look nice. Skin thickness. What you're going to want to do if you're new to this is set this to your extrusion width times your number of loops. The number of loops is the number of loops that you make along the perimeter of your 3D model. Setting your skin thickness to a multiple of this allows for you to use either 3 loops or 2 loops depending upon the thickness of the model. Now, the way KISSlicer works is it will use this value up to 150% of itself to make each loop. Now, depending on the thickness of the skin of your model, this is pretty helpful. Setting this to a multiple of your extrusion width is just a nice rule of thumb, and I suggest that you do it to start off with. Infill style, this is going to change the pattern by which you do infill. Infill percentage, this is going to change the percentage of infill. It's pretty self-explanatory. However, I will give you some rules of thumb. For parts that are not structural, that are made to be pretty, 20% is a good number. Unless it's an overly complex model with lots of small fill areas, and in that case, you would want to set it to a higher value. Somewhere 33% for a pretty model would be a good number. Now, if it's a structural model, you're going to want to set it to 50%. This will give it added structural stability. And also, a note, 100% is not a good idea. Basically, if you don't have your printer calibrated perfectly, then 100% infill can cause you a lot of problems. So setting it to 50% for structural models is a good idea. Setting it to 20% for less detailed artsy models is a good idea. And if it's a more detailed artsy model, you might want to set it somewhere around 33%. Okay, moving over to support. I would suggest that you use medium. I would suggest that you use somewhere between 40 and 55 for your support degrees. Going much higher than 55 will mean that your supports will become more and more vertical, covering less of your model and basically being useless. Going much lower than 45 will mean that your entire model will be covered in support, and it will really not be fun to clean all that stuff off. Setting this to medium ensures that you don't have support that is really flaky that has to be cut off. It's a nice happy medium between ultra and coarse. Coarse, you end up with really feathery support that you have to clean off. Medium ensures that you can at least pull some of the material off by hand. So if your model is something like a dog with 4 legs with an overhang in the middle, support is something that you're going to want to look into. A note on the support, this Z-roof, you set this to a value more than 0, then it will generate support up to whatever value you place in here. If you place 30 in here, it will generate support up to 30 millimeters. Raft. This is something that you're probably not going to need to mess with unless you're having problems with your model adhering to the build platform. What you're going to want to do is set it on skirt if you're not having problems with adherence to the platform, and what this will do is it will prime your hot end by drawing an outline of your entire model. Grid will generate a grid up to this many layers underneath your model. This is if you're having problems with a model that's mostly overhang with very few points actually touching the build platform, grid is a good idea because it will make a base for your print. Prime pillar is something that I don't mess with. You'll generally get everything you need out of skirt or grid for the purposes of this. I also don't use this setting. I'm not exactly sure what it is. If you're interested, check the Googles. Okay. Over in material, we have, this is going to be our material diameter. We use 1.75 millimeter for the delta. Another common size is 3 millimeters. Basically, you place that in there. This is going to be the temperature for your entire 3D print, other than your first layer. These are values that you're going to want to pick from among the recommended ranges for the material you are using. Just go ahead and ask Google about your material and you will find its melting characteristics online. I guarantee it. Start with some recommended values and adjust as necessary. Uh, I will tell you that turning these to a lower value will increase your overhang abilities, but it would also be harder on your extruder. Setting it too low will mean that you will end up having problems because your material is not fluid enough. Setting it too high will make your overhangs terrible, so it's good to sort of experiment with values here. Keep warm, not something you're going to need to worry about. Basically set it to somewhere just slightly below your main temperature. Bed, this is going to be the temperature of your heated bed. 60 is the recommended value for PLA, which is what I'm printing with on this printer. Um, don't worry about the strangeness of these values. Look up your materials and find out what you need for your application. D-string, this is the amount that you will prime and suck on D-strings. This is the distance that you will move on a wipe. For direct drive extruders, it's nice to set a low value here, as it is more effective. This D-string is more effective in direct drive extruders as opposed to Bowden extruders, which we use, and we will have a value closer to 5 for our D-string and a value closer to 5 for our wipe. Now, speed is how fast you retract and prime your D-string. A good value here is to be as high as possible without skipping steps. Excuse me. The minimum jump, any value less than this will not wipe. Basically, you want to set this to around 5 and 10. If you're printing lots of very small parts placed close together, you might want to set this to a lower or a higher value or a lower value. It just depends on if you have a lot of peaks, pointy parts, disconnected parts that are close together. If you have a couple peaks close together, then you're going to want to probably look into this value. Otherwise, you're going to leave this at default, or set it around 5 and 10. These are good values. Fan, if you have a small fan, just leave it on all the time. If you have a lot of cooling, then you're going to want to play with this to turn it down, because as the material cools, it curls, and adjusting these values will adjust your amount of curl if you have adequate cooling. Otherwise, just turn these on all the time, basically. If you don't have a heated bed, it's a really good idea to start your fans at a level other than the first layer in order to give it a chance to cool at a slower pace. It keeps it from curling too much. So if you have no heated bed, you're going to want to turn this, change this value to something like 0.3. If your layer height is 0.3, you would set this at 0.3. That means your fans would start on the second layer. If you set it to 0.6, it would start on the third layer. So that's pretty handy in case you need to ensure that your model sticks to the build surface. Minimum layer speed, this means that it will take 15 seconds for your layer, no matter how small it is. If it's a dot, it will take 15 seconds. This ensures that your material is not too hot and that you're placing material at a slow enough rate that it has time to cool. This isn't going to help very much. Fans are going to be really where you get a lot of value out of cooling your material. Flow tweak, you will change this in case you have different types of materials. Some materials have different thermal expansion characteristics. If you needed to decrease, you would change this to a value such as 0.98. And if you needed to increase it, you could change it to a value like 1.2. This is just something that you're going to have to monitor by measuring the dimensions of your objects. And you'll have a better idea of how to adjust this after you've worked with this for a while. So for now, just leave it at 1 would be a good idea. Do not change these values. I haven't ever changed these values. These are probably good default values. Z lift. This is the amount your head will pick up off the printer each time it does a move. Setting this to your layer height is probably a good idea. If you have to set this higher than your layer height, then you need to calibrate your machine more. You just need to do more calibration probably. Means you're putting too much material out and you're scraping your head on the excess material. So that's going to be something that you're going to need to adjust your flow rate, maybe. Alright, as you can see, there's no material G code. I've never had any material G code, so you can disregard that. We're going to have one extruder. This is pretty self-explanatory. Your bed size, your bed center is going to be determined by your firmware. This is not something you're going to need to worry about, but if you're using a Delta printer, this would be set to 0, 0. Okay. Bed roughness. For your first layer, you're going to, if you have a bed that's not exactly level, you can increase you can put a value in here such as 0.1. Now our layer height is 0.3. This would make your first layer 0.2. Or, I'm sorry, 0.4. So it extrudes a thicker first layer in order to help adhesion. It also helps in case you don't have a heated bed. And Z settle is not something you're going to need to worry about. Z offset is what you would modify this value if you wanted to print higher or lower in reference to what it thinks is where the bed is. This is not something you're going to have to mess with either. Firmware. This is something that you're going to learn about whenever you take a look at the firmware video. I'll go into more depth on this. Extruders, you're not going to have to change anything here. Just make sure that you have one selected. The axis is going to be E since we're going to have one extruder. Speed, you're not going to want to mess with these for the printer we have either. But suffice to say, this is the low speed, this is the high speed, and our slider here picks from among those values. XY travel speed is the speed with which you travel when you're not extruding. A good rule of thumb is to have a reasonably high speed in here. It helps with de-stringing purposes and a couple other things. Z speed, this is a screw type printer. It's called a Mendel-Prusa. I'll show you a picture. So as you can see, this has screws that move the extruder up and down in order to print the different layers. So a very small amount of movement requires a very large amount of rotation. So my Z speed is set to a very low value. On the Delta, it will be set to a very high value, a much higher value than this. And actually, this is too fast. This is throttled in your firmware, and basically you're not going to override your firmware, so this is something you don't need to worry about. First layer max speed, it's good to set this to a reasonable value in order to get adhesion. If you print your first layer way too fast, then you're not going to get very good adhesion. If you print it too slow, then it's going to be annoying. So just find a decent value. If your print is a little less detailed, you can get away with a faster speed. If it's more detailed, you're going to have to make your first layer slower. This can also be controlled in the slider over here, as I said before. The limit increase per layer is a way of throttling up production. So the first couple layers are the most important layers. So as you go up, you can increase your speed without sacrificing quality. Those first layers are the most crucial, and so throttling your speed increase is a good idea. G code. This is the pre G code, and this is the post G code. Uh, for our purposes, you're going to need to research what you need for your pre and post G code for your particular printer model. But for our purposes, basically, we need to allow cold extrusion. This is the G code for that. We need to home in order to get our home location. This picks the printer head nozzle off the bed while it heats up, turns the fans on, and then we set a high starting temperature and wait for it to achieve that starting temperature. Now, since we allowed cold extrusion, if we did not make it pause until we reached our set temperature, then it would immediately start printing without the head being hot enough to extrude material. So this is why we use this line. Post-fix, as you can see, I move to the side instead of homing after I'm done with the print, because if I were to move down to the home position, I might smash my print. So I simply move to the side and turn my heated bed off. Okay, so now that you have an introduction to all of the fields in KISSlicer, we'll go ahead and open up a model. In your list of STLs, you can select your model and you will get a preview over here. With your model selected, when you import the model, you may notice that there are some errors. If you have errors that affect the print quality, you can go ahead and upload that to NetFab Cloud to fix your model, and I will go into depth on how to do that in another video. But suffice to say, your errors are color-coded, and the more red they are, the worse they are. So as you can see, it says I have a little bit of a problem on this corner, but since I've printed this model out before and I've found no abnormalities, I'll go ahead and slice it. And as you can see, it takes quite a bit of time. This isn't a very slow laptop. This is an i5, and it took quite a bit of time to do that. And when you're done, you can save it to the directory of your choice. Now, if you want to resize your model, you can dynamically do that in this interface. There's not much else you can do. You can rotate your model, and you can move the placement of the model with these sliders. And if you need to center it, you can simply place center or push center. So that's all you need to know about KISSlicer. If there's anything you missed, just go ahead and take a look at it again. The KISSlicer software should be set up well enough for you. However, I will cover modifying KISSlicer for the Delta in particular, and the sort of problems that you're going to have in printing out objects that you want to make exactly how you want in another video called Printing Quality Tips. So there you go.